In this video, I'm going to show you how you can analyze data with analysis of covariance in SAS. I'm going to do this with the same data set I showed you in JUMP, that piglet data set. And I've already brought that into SAS using proc import. So remember, we have three treatments that correspond to different diets we're feeding these piglets. And I'm also taking into account what that piglet's initial weight is and what that piglet's end weight is. Because I think the treatment might affect end weight, but so will what their initial weight was. So I need to take that covariate into account. So just a reminder what model we're fitting. We're trying to fit this model for right now where we have an interaction with each treatment. You would want to do some sort of graphical representation to make sure that this model makes sense, but in this video I'm just trying to show you how you can fit this full model, and it'll be clear how you fit any smaller model. So remember, each one of these parameters under this model is no longer estimable. One thing that is estimable is beta plus beta I. So that's the slope for each of the treatments. I'll show you how you can estimate that and get that out of SAS. So let's go back to here. So under class, I only want to put my classification or categorical variables, and that only one is treatment. You're going to be tempted when you first do this to put in initial weight here. And if you do that, you'll see that it takes a really long time to run. So I'm not even going to bother looking at it. It's going to think each initial weight value is a category, which is not what we want. So my model, my response is end weight. And I'm going to say that's equal to, so I'll show you two ways you can do this to do this full treatment by covariate interaction models. One way is to list them out one by one. So I'll say treatment, and then initial weight, and then treatment star or times initial weight. So this is going to do my taus, this is going to be my beta, and these are going to be my beta i's. So that was actually kind of a lot to type out. So one shortcut actually is to get rid of the star and to just put the vertical pipe, which is right above your enter or return key. So what this is going to do is it's going to tell SAS, okay, I want to include all of the main effects and interactions between the things that I'm putting in here. So I'll show you in the factorial model that you can use this to create three-way interactions if you want to. But this is just shorthand for you to be able to do both of these effects and their interaction. So we might also want to do a comparison of our initial weight. So if we go back to LS means, or not comparison of initial weight, comparison of end weight at different treatments. So I want to do LS means, I could do of treatment, and then I'm going to say I want to look at the differences, and I also want to look at the confidence limits in that case. So I'm going to click run. We're going to come back to this in just a minute, just to see what the output says. Okay, so we have the familiar first parts of this output. This residual, that's going to be our estimate of sigma squared. I'm doing this with REML, not the type 3 sums of squares. I'll just stay with REML in this case. And these are the type 3 tests of my fixed effects. So these are going to be fitting models reduced in full models. So when I look at the p-value down here for initial weight times treatment, this is comparing that full interaction model to the model where I just have treatment and initial weight. And I get an insignificant p-value, so you would probably want to proceed by removing that interaction. So the slopes are going to be the same across the treatments, and the slopes are highly significant, as you can tell right here. So let's look at the least squared means. So this 42.0621, so what is that actually estimating? So at what value of my covariate is this my estimate of what the effect or what the average is for treatment 1, treatment 2, and treatment 3? So to figure that out, we're going to have to go back to our notes. So these are, again, adjusted treatment means. So we're going to be looking at this part right here. So that LS means, without me telling what covariate to look at, is going to be looking at the average response for that treatment at the overall covariate average. So whatever my average initial weight is, that's where that value is coming from. So the model involves the covariate, so my means have to involve the covariate value at some point. And so that's what the default is. So that's what these estimates are, and that's where these comparisons are being made. So these are comparisons when all of my treatments are at the overall covariate average. So you'd have to be able to figure that out, what that overall covariate average is, to know where this is happening. So my comparisons here look very consistent. My standard errors are all pretty much the same. Treatment 1 is different from treatment 2, treatment 1 is different from treatment 3, and treatment 2 is different from treatment 3. So all these are significantly different from each other. If I wanted to do this comparison at another covariate value, you could do that with LS means. So you could do this with the at and then say initial weight equals, and let's say we want to do this comparison when initial weight is 10. And so I'll run this code again, and we get very familiar output, except now the LS means and the differences of LS means is telling us our initial weight is 10. So these differences are not as high of a magnitude as they were before. Our standard errors increase a little bit, and this is because we're getting closer to the boundary of our covariate range. But we still see that our estimates are statistically significant. Maybe not as much as they were before, but that's because the standard error is increasing. And SAS is telling you that the comparison is being made at initial weight 10. It's giving you that warning right there. Okay. So now let's look at how we can compute kind of custom estimable functions, which wasn't really available in JUMP directly. So this is one advantage of doing your analysis in SAS, is you could do maybe some more customized testing and estimation. So for example, if I wanted to get an estimate of the slope for treatment 1, now this would only make sense if you had if the interaction was significant. So I'm just demonstrating this to you now, but when you do this analysis, you would probably want to drop that interaction because it was insignificant. But in case you wanted to keep that interaction term, this is how you would do it. So if you want to get estimate for slope 1, we have to give this some name, so maybe just S1. And I need to tell it which parameters to estimate. So remember, my estimate for the first, my estimate for slope 1 isn't going to be beta 1, it's going to be beta plus beta 1. These beta i's are adjustments to the overall slope. And you'll see, if I wanted to do just beta 1, I might try to do that by saying treatment times initial weight and say 1, 0, 0. So this is me saying, I want to look at my beta i's, and I just want to look at what beta 1 is. So remember, that's supposed to be not estimable. So let's see what SAS does when I run this. So SAS is telling me this is not estimable. It can't actually do that estimate. So SAS is very familiar with estimable functions, and this is why I'm using non-full rank models in this class, is because that's what SAS uses. So if I actually wanted that slope estimate, then I need to also add initial weight and add a 1 there as well. So this is going to give me beta plus beta I. And I'll click run on this. And there's my estimate right there for slope 1. Likewise, if I wanted to get an estimate for slope 2, I could do 0 and then a 1 right there. And I would get my estimate for slope 2. But don't forget, I forgot to do it, but I don't want you to forget that you probably want to change your label. So I call this S1, but it should be S2. So you want to change that label. That's the one downside of this, is you have to make the custom labels. And so this is actually doing a test for whether beta plus beta 2 is equal to 0 or not whether beta 2 is equal to 0. So keep that in mind. Okay, what's another thing that we can look at? Let's say I wanted to do my treatment means at a given covariate value x star. So we started to do that with LS means. So here I was getting my estimates for when initial weight was 10, but I can also do that with the estimate function as well. So let's say treatment 1 mean at x equals 10. So I found that out with LS means, but let's see how we can do this with the estimate function. So the way I'm going to figure out how to do this is I have to go back to my model and know what that treatment mean is supposed to look like. So this is what my adjusted treatment mean is going to look like that's the adjusted treatment mean. But if I want an arbitrary treatment mean at a given value x star, this is the combination of parameters that I want. So I want to put mu in there, I want to put the tau in there, and beta I, whichever treatment that corresponds to. So I want this to be tau 1 and beta 1. And that should be estimable. So the way I do that is to get SAS to include the intercept, I'm going to type intercept and put a 1. And then I'll put treatment and do 1, 0, 0. And then I also need to include the beta parameter for initial weight. That needs to be, you'd think it would be a 1, but it can't be just a single 1. It actually has to be the covariant value. So I'm going to make this a 10 because that's the covariant value that I want. And then I also need to include treatment times initial weight and make that a 10, 0, 0. So it's a 10 for treatment 1 and zeros everywhere else. And so if this was not estimable, SAS would give me a warning that it's not estimable, but I'm fairly certain that it's correct. And there we go. And notice this value is exactly the same as what we had in LS means right here. So I was able to type it in the way I wanted to. So if I wanted to recreate these differences at 10, I need to go back and look at what my combination of parameters should look like. So if I wanted to compare treatment 1 and treatment 2 at x star, I need to create this combination of parameters in my estimate statement. So I need to do tau 1 minus tau 2, and then beta 1 minus beta 2 times what that covariant value is going to be. So this is why it's important to be able to take expected values and know the model so that you can recreate these tests in SAS. So if I wanted to estimate T1 minus T2 at x equals 10. So I was able to do that with LS means, but I'm going to show you how you can do this in the estimate statement. So I don't want that mu parameter in there anymore. So I'm going to do treatment 1 minus 1, 0. I don't need initial weight anymore because that overall beta parameter cancels out. So I just need treatment times initial weight, and I'm going to do 10 minus 10, 0. So again, I need to keep the covariant value in the interaction term right here, and the pattern of pluses and minuses follows the same as before. So I'm going to run this, and I get 4.6926, and that's exactly what I get down here. So this is just me showing you how you can recreate that. Now the last thing is one thing that you can do in SAS that you can't do in JUMP is, again, this test up here is testing whether all of those beta parameters, those extra beta parameters, are necessary or not, whether they're equal or not. So one thing you might want to do then is if this came out to be significant, you might want to test, well, which slopes are actually different from the other slopes. So I'm talking about a custom test where I'm testing maybe beta 1 minus beta 2 and seeing if that is significant or not. So you could do that also with the estimate statement. So you could say slope 1 minus slope 2. And all you need for that is treatment times initial weight. And then you do 1 minus 1, 0. So this is doing a comparison of whether beta 1 and beta 2 are equal to each other. And that turned out to be estimable, and the estimate is very small. So there's basically no difference between those slopes. So again, this would be a test you might want to run if the interaction is significant. And in this case, we're not surprised to see that it's also insignificant because the overall test was as well.